Okay, so I want to talk a little bit about this type of problem. This is a common thread through the whole course, and basically we've been provided with the right triangle. We know one of the sides, which is not enough to pin down the rest of the triangle. Really, if we know two things about the triangle, we know two sides, we know an angle and a side, and it's a right triangle, then we'll know enough to be able to pin down the whole triangle. And in fact, generally, where we're going this next little section is what we're actually saying is if we have three pieces of information about a triangle, we can pin down the rest of the information. And in a right triangle, of course, one of the pieces of information is the 90 degrees. So with two more pieces of information, we can figure out the rest of the triangle. And so mathematically, if I tell you the value of cosine or sine or tangent or cosecant, secant or tangent, cotangent, then I've given you enough information to do it. And that's basically what's happening here. Now we're going to approach this problem in a couple different ways, just so you can get the hang of it. Making a right triangle is generally going to be an option for you in a lot of situations. So this is a nice technique that you can use to help you solve problems. So first of all, I'm going to write down, oh, I'm sorry. This should be cosine alpha, not cosine A. A lot of times we'll use these sort of pairs, sometimes use lowercase letters, sometimes use Greek letters. So cosine alpha, all right. And of course, it's important for us to be clear about what angle we're talking about because depending on the angle, the adjacent side is going to be different. So cosine alpha here would be b over 10, adjacent over hypotenuse, and we know that's 2/5, so we can solve this problem for b. So basically we have 5b equals 20, b equals 4, and if b equals 4, then I can do the math to figure out what a is equal to. 10 squared equals 4 squared plus a squared. So we're looking at 92, no, sorry, 84. That's a good example of a misfire. A squared is 84, and so a equals the square root of 84. You could simplify that yourself. 2 square roots of 21, looks like. All right, so I wanted to find tangent A. I now have done all the work that I need to do to find it. I was just kind of on a mission to figure out all of these other angles. And of course, this is a way to do it that doesn't go through an approximation process. Now, of course, we could have gone with the inverse cosine. Oh, sorry, getting ahead of myself. We haven't talked about that yet. That didn't happen. All right. So tangent A, opposite over adjacent. Oh, sorry. This should be alpha 2. Oh, boy, all kinds of mistakes. Need another cup of coffee. All right. Tangent alpha is A over B. And so we know A is 2 root 21. We know B is 4. Simplify it. It should be 21, not 11. And so we're looking at the square root of 21 over 2. So that's one way to do the problem. And I think this is an important way to kind of start your thinking about the process. Eventually, we're going to discover that we don't need to go through a triangle representation because there's other ways we can put these things together. For instance, and I'll just give you a little preview here. There's a Pythagorean theorem in trig land. We know the Pythagorean theorem in, I don't want to clear everything. Let me just clear this out here. So, oops. So the Pythagorean theorem in regular terms is a squared plus b squared equals c squared, where we've got the two legs, a and b. And then we have the third side, the hypotenuse C. So I'm going to go ahead and kind of orient ourselves in this corner. So the cosine of alpha would be the adjacent B over the hypotenuse C. The sine of alpha would be A over C, and the tangent of alpha would be A over B. So a couple things to point out here. If I divide everything by C squared, just for fun, this is going to be A squared over C squared plus B squared over C squared equals 1. And this leads to the first Pythagorean statement in trig language, which is that A over C squared plus B over C squared is equal to 1. In other words, sine alpha squared plus cosine alpha squared equals 1. And typically we write that with that square symbol, we write that on the sine and the cosine part. So sine squared alpha plus cosine squared alpha. Just to be clear, we're not saying the sine of alpha squared and the cosine of alpha squared. I wrote the parentheses there, but in order to avoid having to write the parentheses every time, we've just put the square on the sine and the cosine. But what that literally means is sine alpha times sine alpha. Okay, so that's a Pythagorean statement, and that would actually allow us to get to sine alpha from cosine alpha, because we could have just said, well, if cosine alpha is 2/5, then sine squared alpha equals 1 minus 2/5 squared. And then we can go from there. Now, we weren't actually looking for sine alpha, we're looking for tan alpha, but there's a way to connect sine and cosine together to make tangent. Think about what sine alpha divided by cosine alpha would be. A over C divided by B over C. Okay, well, let's write the fractions sideways. A over C divided by B over C is really A over C times C over B. Simplify A over B, and lo and behold, A over B is the same thing as tan alpha. So we can get to tan alpha by taking the ratio of sine alpha to cosine. Now, all that may seem like, crazy talk right now, but as we go on, those are going to be critical elements to your toolbox. All right, onwards and upwards.